Did you know that every single day we create roughly 2.5 quintillion bytes of data? It's increasingly obvious that our world's being dominated by big data, so it's important that we keep up. The first step here is to use descriptive statistics to make sense of the vast quantity of data that we have, and in turn extracting valuable insights from otherwise unmanageable data. This is also usually the first approach in any data science project. So what are some of the key measures we use in descriptive statistical analysis? One of the groups of measures is known as the measure of central tendency. Here we use a value to summarize the central point of a given dataset, and often these are called averages. The three most common measures are the mean, median, and mode. The mean is simply the sum of all the values in the dataset divided by the number of observations. The median is the middle value in your ordered dataset. And finally, the mode is a value or category that occurs most often in the data. So consider this example dataset. We can see that the mean is the sum of all the values, which is 27, divided by the number of values, which is 9. This gives us a result of 3. The median happens to be the middle value, which is the 5th position, and this happens to be 2. And finally, the mode is the most commonly occurring value, in this case also 2. But what measures of central tendency often miss out is the variability in the data. This is where measures of variability or dispersion come in. These give a numeric value to how spread out or varied our data is. Imagine you have two factories, and a column needs to be produced to handle 100 kilos. If the column can't withstand this weight, the building's at risk of collapsing. Through some research, you found out that two factories produce columns with a mean strength of 110 kilos. But upon closer inspection of the data, you see that the variability means that one of the factories has a chance of producing a column with strength below 100 kilos. This is an example of why measures of variability are so important. The simplest measure of variability is the range. It's the difference between the highest and lowest values in a dataset. But if we're more concerned about the bulk of our values, we might use the interquartile range, which finds the difference between the 75th and the 25th percentile of our data. But by far the most commonly used measure is the variance. It's a measure of how spread out the data is from the mean. It's calculated by taking the squared difference between each value and the mean, and then averaging the squared differences. In the case of our previous dataset, we saw this as 16 over 3, where we take each value, such as 1, subtract the mean, which is 3, and square it to get 4. Do this to every value and you get 48 over 9, which is 16 over 3. You may have also seen this presented as a standard deviation, which is simply the square root of the variance. But sometimes the measures of central tendency and variability don't give us the clearest picture of our data. That's why we also use measures such as modality, skewness, and kurtosis to describe our data. Modality refers to the number of peaks or modes in our dataset. For example, a dataset might be unimodal, bimodal, or multimodal, based on how many peaks we have. And skewness is a measure of the symmetry of our dataset. We could have more smaller values, or a lot of large values. And finally, kurtosis is a measure of how much data is contained within the tails, or the tailedness of the data. You may have noticed that our measures are just covering one variable, or a univariate dataset. But what happens if we have more complex data, such as paired data points? How can we summarize these variables? Well, a simple approach is just to calculate univariate statistics on both of these sets. Or we can use something called correlation, which seeks to identify the strength of the relationship between the two variables. There are a number of ways of calculating this, such as a Pearson or Spearman's correlation. But the general idea is, if a value is positive, there's a positive link between the variables, so as one increases, the other tends to increase. And the reverse is true for negative correlation. So that's a quick intro into descriptive statistics, the first step in data analysis. I'll be releasing weekly tutorials and explainers and monthly project videos covering mathematics, statistics, and programming. So consider subscribing and hitting the notification bell for future content.